Guys, welcome back to the channel. This is a bit of a different video this time. So I'm going to do deep diving into the comparisons of products within the circuit protection range. So if you're not an electrician, you're not electrically minded, and you don't give a monkeys about circuit protection, I'm sure there's a video about cats that you'd find far more enjoyable. But this one's going to talk about the history of MCBs and RCBOs, where they've come from, how they've evolved, where they are still very prominent in today's market, and they both still have a place in the modern installation. And we're going to correlate that all with our favorite book in the world, BS 7671. So without further ado, let's dive straight into it. So an MCB, or miniature circuit breaker, has actually been around since the 1920s. It was invented by someone at Siemens, whose name is, bear with me, Hugo Stotz. Now, I've repeated that at least 6 times, and I think that's the correct way of pronouncing it. I really do hope he actually got royalties on an MCB, because they were launched in the 1920s, as I say, and today is 2025. That's a lot of royalties. I don't know how royalty law works, but it would probably be a very rich man. So these were invented to improve safety, speed, but also prior to an MCB, if your fuse went pop to protect you on the circuit, that entire fuse would need replacing. You couldn't simply reset it like you can do on a modern MCB. So as you can imagine, it was absolutely revolutionary for its time, and then maintained an absolute staple within the industry up until today. So what do MCBs protect against? Well, simply put, they protect against overload, which is when a current is going through the device towards an appliance or circuit at a higher load than it's intended to. So, for example, if you've got a ring main on a 32 amp breaker and it's pulling 40 amps, it will trip before it hits 40 amps to keep everything on the circuit safe and everybody in the home safe. And then you simply go back, you reset it, and we continue on. What does it also protect against? It protects against short circuit, which is when the line and the neutral connect, usually due to a fault, okay? So then it will quickly trip to keep everybody safe, hence protection devices. So that's what an MCB is designed to do. Now, without going over too much old ground, homes and circuits and electronics and appliances and everything else in our homes certainly has changed since the 1920s. For the fact that in the 1920s, not every home had a warm shower. Now think about that next time you're in the shower in the morning. Something is, 60 years ago, not everyone had a warm shower in the house. Obviously, that means your circuits and everything else has definitely evolved, especially since a lot of those showers now are no longer gas, they're actually electric. So circuits have evolved, appliances have evolved, and pretty much everything we do and everything in our world has evolved since the 1920s. So as this has migrated through, there's been some elements of MCBs where it doesn't cover that have come to the surface. One of those is that these devices, as great as they are, do not have any or do not provide any protection against any form of earth leakage whatsoever. This is when the RCD was introduced. So an RCD, which is a residual current device, okay, in its proper form, protects against, doesn't provide anything, it protects against earth leakage. Depending on the RCD, it shows you a 30 milliamp rating or 100 milliamp rating. Some of them have time delay features and they're quite sophisticated bits of kit. But they are specifically there designed to protect against earth leakage. None of the protection that an MCB gives you. So it doesn't give you the same overload protection, it doesn't give you a short circuit protection. Okay, and this is where the original RCD boards, now I'm talking pre-split load boards, came from. So you would have your incomer or your RCD protecting a bank, an entire row of circuits. In fact, I think my parents' house still has one. We should probably do something about that, to be fair. So it will have a single RCD protecting a large number of circuits. Well, there's only so long it can do that for before actually, as we talked about on a previous video with split load consume units to the RCBO evolution, that nuisance tripping will become more and more apparent because you're going to have an element of earth leakage because of appliances leaking current to earth, just creating nuisance tripping along with other host of problems there. And that's where we moved in and migrated to a split load consume unit. So we're still hanging off the coattails of the MCB that's been around since the 20s and just providing it extra levels of earth leak protection as the circuits and homes and everything else became more and more sophisticated. So somewhere along the line in the 1980s, someone had the idea. Now, I haven't been able to find out who it was or what company they worked for. But in the 1980s saw the rise of RCBOs. Now, I say rise because it wasn't really until probably over the last 7 or 8 years, we've really seen it impact the domestic market, more commonly found on the commercial settings, and that's simply down to the fact they were bloody expensive. But this RCBO revolution, as it's now become, is a hybrid between that MCB that you can see there and the RCD that we've mentioned before in a single unit. So now all of a sudden, you have this RCBO that gives you all of the elements that we've come to love over the 100 years of using MCBs, and that 30 milliamps worth of protection of earth leakage on every single circuit that is you use an RCBO on. So that in itself was revolutionary. And like I say, since COVID really has become a staple now, and in parts of the regs, some would say mandatory use on final circuits in the home. So some important things to note. Now, I've touched on this in previous videos as well. BS 7671 and manufacturing standards are two very separate things, okay? So the BS 7671 regulations are what installers are mandated to in a way, I suppose, and they are the guidelines that you are held accountable for. BS EN numbers and the other EN numbers and other structures is what we are held accountable to, and you'll see them referenced in BS 7671. So, for example, it will say, use an MCB. Now, obviously, MCBs have changed over 100 years, right? So use an MCB that currently sits on the BS number, which is BS EN 60898-1. RCBOs likely, which I got wrong in my last video, BS EN 61009-1. Pretty much very boring stuff, but that's already, you won't even have to think about that again unless something really drastically goes wrong. You'll be fitting those standards anyway, but it's also important to know. So the important thing about those standards is they will actually set the characteristics and the kind of scope in which your devices have to work. So for example, an RCBO now, same as a MCB, has certain tripping times that it needs to work within, okay? So that they do vary and there is a scope, and obviously the better the RCBO, the quicker it trips, the higher the quality control process is, the quicker it trips, but also is more consistent at that tripping time. For example, ours are one of the quickest to trip and are accurate within 0.2 milliseconds of one another, which I'm still to believe is pretty much market leading. Just thought I'd drop that little penny in there. Okay, so there are obviously manufacturing standards that we all have to adhere to, and as long as your product fits within that scope, which can be quite broad on certain products, it is compliant. And then BS 7671 will tell you how to fit that correctly. So when should we still fit MCBs? For example, like I've already said, in BS 7671, most domestic circuits are pretty much recommending or standardizing RCBOs across the board, which is the right thing to do. But is it right to throw an RCBO on every single circuit? No, it's not. MCBs, even after 100 years, still have a vital place within protection. For example, if there's already an RCD upstream, or you're on a TT system that has a time delay RCD upstream, the last thing you want is to put an RCBO on there, because you then have RCDs basically working in parallel. Okay, now this can create selectivity issues, which is not a good thing. So when should you fit RCBOs? We've already touched on it on all domestic circuits, especially up to 32 amps on a socket. Regulations 411.3.3, domestic lighting circuits 411.3.4, and to reduce inconvenience during faults, regulation 314.1. So circuits supplying modern appliances that leak earth by that have earth leakage by design, obviously, then you're going to hit that 30% capacity that you're supposed to, you're supposed to stay within, which is very difficult to do on a single circuit, very easy to achieve, unfortunately, on a group of circuits. Again, arc back to the other video that we did. So it's not about not using one instead of the other, because don't forget, for example, MCBs have been bidirectional, which we haven't even touched on yet, bidirectional for a number of years. That tall RCBO you see there is only single pole, same as that AC RCD there, but it's got a type A RCD in it, but it also has a solid neutral in it. There are other RCBOs, other devices, which we've also touched on with white papers and other videos as well. So I don't want to regurgitate everything. Just check out the other videos, which will pop up over there. And by all means, if you've got any questions on MCBs or RCBOs or on any protection device, especially if we make it, please feel free to give us a call. And until next time, guys, thank you very much. But before you check out just there, I don't know if I've lost a few of you already, but before you check out, just remember, we are about 30 people away from hitting 7,000 people on Instagram. And we are less than 100 people away from hitting 2,000 subscribers on YouTube. Now, for those who have watched the end of some of my most recent videos, once we hit 2K on this and 7K on that, we will be giving away 50 12MX consumers. So the 12MX has 10 usable ways and our Type 2 hybrid SPD kit. That, of course, comes with an MCB because it is required by BS 7671. So guys, we'll be giving away 50 of those for free, and we're that close. So guys, if you haven't already and you find any of these videos useful, just click subscribe, share it, like it, do the whole shebang. And if you don't already, just head over to Instagram. It's at Navitas CP. Click it a follow. Send us a wave. And if you don't have a stockist near you that supplies Navitas, get in touch with me directly and we'll sort you out a discount code for the website. So guys, until next time, please remember, it's all about the power, and we'll see you soon.